So in this module we're going to talk about narrow windrow burning and how it works in practical terms. I started working with narrow windrow burning with the Messina family in Mullewa in about 1999, and they'd been narrow windrow burning for a couple of years by this time, and this is their chute. They made this narrow windrow burning chute when they first started using this practice, and they haven't modified it at all. They got it right first off. So that was a great effort, and they've also gone to the extent of having engineers draw CAD drawings, and you can download those CAD drawings for a narrow windrow burning chute if you'd like to copy their design. The thing about narrow windrow burning, as we've already talked about in the nutrient module, is that we are taking all of the residue that enters the front of the harvester. So everything that goes in the front comes out and ends up in that narrow windrow. So all of the chaff and all of the straw. This picture here is of a 3.8 tonne per hectare wheat crop where the Messinas are using narrow windrow burning. Now this crop is arguably a little bit too high yielding for the ideal narrow windrow burn, and you can see the size of the windrow that's been created there, but they were patient and they managed to burn this crop. So ideally narrow windrow burning is used in crops up to about 2.5, perhaps 3 tonnes per hectare yield, but in some instances growers have been able to achieve a good successful narrow windrow burn in higher yielding crops. Some of the science behind it, Michael Walsh and Darren Chitty measured this a long time ago. How hot does a weed seed have to burn to destroy it? And what they found is that wild radish takes 400 degrees Celsius for 30 seconds, whereas annual ryegrass takes 400 degrees Celsius for only 10 seconds to destroy 100% of those seeds. If we have a look at the burning temperatures that we're achieving with narrow windrow burning, this is once again Michael Walsh and Darren Chitty. They compared a narrow windrow with a wide conventional windrow with the burning of a standing stubble. And what they found is that both the very wide windrow and the narrow windrow achieved that hot enough temperature to destroy the weed seeds, whereas the standing stubble got to about 300 degrees Celsius for only a few seconds. So narrow windrow burning, staying hot for a long time, is more than enough to destroy all of the weed seeds in that windrow. So if we compare narrow windrow burning to just burning a standing stubble, these graphs show us that for ryegrass, where we burn a standing stubble and we achieve that 300 degrees, maybe 400 degrees for a few seconds, that can do quite a good job on ryegrass. Whereas with wild radish, because wild radish needs a longer burning time for the same temperature for longer, then we often don't achieve a good seed set control of wild radish when we burn just a standing stubble. So this really shows the benefits of narrow windrow burning for a weed like wild radish, where it needs to achieve that 400 degrees temperature for a longer time. So let's talk about the practical implications and what is the art of narrow windrow burning. How is it done successfully, and what do you need to put in place to do a good job? Rule number 1, harvest low. Beer can height is the height we often talk about. A beer can is actually 13 centimetres high, but we're talking about in that 10 to maybe 20 centimetre harvest height to get as many weed seeds in the front of the harvester as possible, but also to leave that stubble short so that the fire doesn't get away at burning time. Step number 2 is harvest low. Step number 3 is harvest low. So look, it's really important for those reasons. We need to harvest low so that when we burn those fields, burn those narrow windrows, we keep the fire in the windrow. And of course we want to maximise the number of weed seeds that go in the front of the harvester. The next thing we can do is pick the right day for burning. So a lot of growers get this instinctively right, but there's also some tools that we can use. So the MacArthur Grass Fire Index, you can find an app for this or find it online. It's about using the temperature, humidity and wind speed to predict the fire risk. This is the fire risk that we see on the fire dangers that you see around the place. So when we have a MacArthur Grass Fire Index between 2 and 10, it's ideal conditions to get a hot enough burn of the windrow, but without that risk of a fire escape. And ideally, we have a light crosswind when burning narrow windrows. So if we light the windrow up in multiple points along the paddock, if we have a light crosswind, the fire will creep slowly in both directions and the wind will fuel the fire all the way to the soil surface where the weed seeds are and make it hot at the soil surface. If it's dead still, we can get the fire smothering itself and not getting hot at the soil surface, Or if we have the wind blowing down the rows, we can have the fire travel fast in one direction and slow in the other, and that can be a fire escape risk. So a light crosswind is ideal. And growers, particularly with big paddocks, find that they often will light up every 200 to 400 metres. They'll often burn the boundary laps, do the first couple of boundary laps, get them done, that creates like a fire break, and then go and light up the up and back windrows. Up and back harvest is ideal. Round and round still works, but up and back is ideal because we can choose that light crosswind. Now, if they light up every 200 to 400 metres, the whole job can be done in just a few hours, and then they don't have to stay out all night tending to fires. If we have a look at the cost of narrow windrow burning, it's very cheap to get into. Farmers make their own chutes, so that's essentially free, or for just the cost of a little bit of steel, it's very cheap to modify the harvester. We estimate a couple of dollars per hectare for the labour to go and burn the windrows, so there is a cost there, but once again, that's often just the farmer's time. But the hidden cost in narrow windrow burning is that nutrient removal cost. We're putting about 50% of the residue from the field in that narrow windrow. We're burning it. Most of the nitrogen goes up in smoke. Most of the potassium stays behind, but we're putting the potassium-rich strip in the same point every year, in the same strip every year. So if we're using narrow windrow burning on a soil that is potassium responsive, that needs potassium fertilisers, this is a real cost. And the combination of just that nitrogen and potassium equates to about $7.50 per hectare per tonne of grain harvested. So a 2-tonne crop, we're talking about a $15 per hectare nutrient removal cost. So this is a real cost, a significant cost, and we need to consider this when we're looking at this tool. Okay, let's take a look at the pros and cons of narrow windrow burning. Firstly, the pros is ease of adoption. It's very easy for farmers to make a chute and modify their harvester and get into it. There's a low capital cost, costs almost nothing for that chute. And all of the weed seeds that enter the front of the harvester end up in that windrow, so we don't need to modify the harvester at all. And the residue removal can improve the efficacy of pre-emergent herbicides. So look, it does have some good pros, but there are some cons, and of course we're using fire. So fire escapes and smoke are a big factor. There's the nutrient removal cost that we've talked about. There's a residue removal cost, so for soil biology and moisture retention. There's the challenge of burning the windrows without burning the whole paddock, and then there's the challenge of achieving a good windrow burn over an entire farm. So it's very hard to get the conditions perfect for a big farm if you're doing lots of hectares of narrow windrow burning. And it's time consuming. Someone's got to get out there and do it, and it does take up a lot of time, and often it's done of an afternoon and evening and into the night, depending on the fire restrictions in the region. So look, it can take up a lot of time, and it can take up valuable family time at night. So where is the best fit for narrow windrow burning? Well, for my money, it's in the low rainfall zone. It's a low cost tool, and because we're in the low rainfall zone, we have lower yielding crops. It's easier to keep the fire in the windrow, and with a lower yield, we have a lower nutrient removal cost. Ideally, we're talking about high potassium soils. If we're on sandy soils that are potassium responsive, there's a big potassium cost, but some low rainfall areas have high potassium soils, and that potassium cost is not a big factor. And also there's canola and pulses in the medium and high rainfall zones. That can be very easy for growers to burn canola and pulse windrows without burning the whole paddock, but there is still the nutrient removal costs, of course. But pulses and canola, much easier to burn the windrow without burning the whole paddock. So the summary of narrow windrow burning, it's a very popular practice. About 30% of grain growers in Australia are using the practice. It does have its challenges, but it can be a very good proof of concept for you to get into harvest weed seed control and then perhaps move to one of the other tools. Or if you're in a farming system that really suits it, narrow windrow burning may well be a good tool for the future.